to Jack. I mean, one of the things everyone says is, this sounds extraordinary and amazing. You're taking in the idea of quantum physics and applying it to computing. You're going to get superpowers with computing. It all sounds very, very Star Trek. And it's probably like 5-10 years away. But you say that you're already deploying some version of this right now. Can you tell us what you're actually doing? Again, if you can keep it to 2 or 3 minutes and make it intelligible for the non-scientist, you get a brownie point.
Sure. Usually when we talk about quantum, we have champagne or wine in the room because it's much easier when people have been drinking to talk about quantum.
I thought Silicon Valley had psychedelics.
We'll do our best. Anyway. We'll do our best. We'll do our best here. The first thing to say is that, building what Jeremy said, is that beyond just quantum computing, there's other quantum technologies that are here and now that we also need to bring into this conversation. So when we think about quantum computing is a core bedrock, but we also have, for example, quantum sensing. And in quantum sensing, we can build diamonds that instead of just being made of pure carbon, we dope in some nitrogen, we make them slightly different, we grow them from scratch in a facility, these are not from the ground, and we can use these diamonds as very sensitive magnetometers. And what can we do with these? We can actually detect, for example, the very faint magnetic signal of your heart. Everyone here, I'm sure, has had an ECG, electrocardiography, but now we can do MCG, Magneto Cardiography. And one of the reasons why cardiovascular disease continues to be one of the top killers in the world, here in Europe, in the US, around the world, is that we don't have good enough diagnostic devices. But going into the magnetic realm, using quantum diamonds, using quantum sensing, we can now start to do that. Another application that we can do again in the near term is navigation around the world without GPS. Right now, Russia is blocking and jamming the signal of GPS over Ukraine to frustrate the Ukrainians. But using the orthomagnetic field, we can actually navigate. Birds do that, whales do that. We, humans, can now do that. So quantum sensors we have a device right now in clinical trials, so we can do these things in the very near term. We don't need millions and millions of qubits. When it comes to quantum computing, it's a critical, fundamental technology. We are the first generation of humans that will not only have wonderful activity in the bits world, but also now in the world of atoms. And as just building on what Jeremy said, it's critical to not just the chemistry also of the body, but also, for example, material science for clean tech. If we want to have better batteries for electric vehicles, better batteries to store renewable energy, we need to simulate these kinds of molecules and atoms in using the quantum equations. And this is why this is a fundamental shift in how we do computing.